Welcome in, everybody. There's plenty of room at the side, so keep streaming in. I'm actually going to get started because there is a ton of stuff to cover today. If you're late, don't worry, you're only going to miss the intro. It won't be that relevant. Right. Welcome, everybody. Welcome to What's in the Box, a Tableau Server deep dive. My name is Tom Christian. I'm a solutions consultant here at Tableau. Effectively, and I suppose purposely for this training, a lot of the content that's going to be in here is the type of things that I talk about on a daily basis. A few housekeeping points. Unfortunately, as I said, there's lots of content. So I'm going to save questions for the end. There should be a good 10-minute chunk right at the end, so if you do have burning things that you need answering, feel free to ask it then. I'll also stick around at the end for any particular specific questions. And in terms of who I am and why I'm stood here in a tiger-based shirt talking to you all today, these are a few things about me. If you're close enough to see, I love stickers. I was going to give stickers away and then stuck them on my laptop instead. But mainly, as I said, so this topic, Tableau Server, is something I talk about all the time. And more importantly, it's something that I teach our own internal sales consulting team about this stuff all the time as well. So you're actually sat here getting the same training in a condensed amount of time that I would normally give to the people that do my job. It's also, I consider this session really important because just by show of hands, who here classifies themselves as a server admin? Who would like to be a server admin? Okay. Who's here because it's a good opportunity for an after lunch nap? Good, nobody put their hands up. So mainly the reason why I see this topic as being super important is the fact that you all have likely invested a large proportion of your time and money in Tableau Server. And it's best to get the most out of that investment as possible. So a lot of the teaching that will be here today will fit that gap to make sure that you know at least roughly the levers that you can pull and tweak to make sure that you're getting the most out of Tableau Server and understanding what's going on. I've made a few assumptions. So like I said, for most people in the room, I'm targeting you as if you're a server admin. If you're not, and that freaks you out a little bit, don't worry. There are plenty of jokes. You should also classify yourself as intermediate. I don't know what that means. Nobody seems to know what that means. Oh, that animation wasn't supposed to happen. But anyway, you classify yourself as intermediate, and that can fit a wide range of people that have used Tableau Server for years and years and people that have never touched it. So I'm going to try and ensure that there's enough learning to hit everybody's needs. That is my challenge. And mainly, I hope you're interested in learning and enjoy potentially relevant memes and pictures because there will be plenty of them. Number one, Tableau Server. Tableau Server is a black box installation. So there it is, floating through space, the clouds. Tableau Server has many different components, and up until today's keynote, if you were listening to Francois talk about the repository changes, we tend to not let you customize it with your own parts, your own bits of hardware. So you have to almost trust us that it's going to do what we say it's going to do, which can be a very scary thing for anybody. It can leave you feeling a bit like this. What's in the box? What's in the box? You'll find out. But first, 2017. I went to find some relevant things that happened in 2017. Look it up, nothing good happened, so I refused to put them on the slide. But you will see a picture of Tableau Server. Tableau Server in 2017 looked like this. It's quite nice. There are a couple of processes. It's kind of familiar for those of you that have been around that long. Seeing Tableau Server like this makes me feel pretty happy. I'm comfortable with all the components. And then let's fast forward to 2019, and it looks a bit like this. That list has expanded massively. We've included new processes. We've introduced new features. That's the word. We've got new features. And also, we've split things out into subcomponents. So That allows you to monitor exactly what's going on, but it means you've got to keep more things in mind. Can leave you feeling a bit like this. So if we look at what happened in 2018, we saw the cluster controller, TSM was introduced, the licensing service comes up as its own component now. 2019, we have microservice containers, you've got prep conductor, ask data, the Elastic server. This list is growing, right? There's a lot to keep in mind. So today, I'm going to be taking you through these processes and introducing you the purpose of these processes. Why are they there in the first place? Why should you even care? I'm going to point out any recent changes, as well as things that really you should just know. We'll follow that set structure this whole time. And possibly the most important for all of you today is what can you do to ensure that you can optimize and get the most out of these processes. The larger you grow, the more complex your environment, the more you have to keep these things in mind. And most importantly, I want you to feel like Happy Drake all over again. Right, Tableau Server again, this time with a deep dive of processes there on the screen. This is going to be our guiding light. So as I said, we're going to cover what does it do, how does it do it, and the best way to do this in my mind is to go through this from the eyes of a user journey. So when a user comes to Tableau Server and they start interacting with things, they're going to start lighting up certain processes as they do those things. So I'm going to introduce you to our first user. Our user is no stranger to love. In fact, he knows the rules and so do I. But does he know Tableau Server? Yes, our user is Rick, and Rick's going to go to Tableau Server, and the very first thing he hits is going to be the gateway. So the gateway, what does it do? When a user comes to Tableau Server, as I've just said, the way that they communicate with the server is actually through HTTP requests. Whether that's from the web browser, from Tableau Desktop, when they're communicating and hitting the server, what they're actually doing is sending HTTP traffic requests that are hitting the server and telling it what to do with that request. So the first things first is they're going to hit the gateway, and the gateway is going to route on to where it should go next. So the gateway is the thing that's basically going to divert all the traffic where it needs to go. Next up, if you have a multi-node environment, if you have a Tableau Server cluster, what the gateway is going to do is, as soon as that traffic hits that server, it's going to determine where it should go next. So it goes to the gateway, and it's going to go, OK, this is going to go to node 1, this goes to node 2. And the way that it does that is in a round-robin fashion. So it's going to hit it, it's going to go 1, then 2, then 1, then 2. If you've got 3, 1, 2, 3. It's going to do it in that order, up until the point that that node gets overloaded. And also importantly, if you have a custom logo or some static files, it's actually the gateway that's going to serve up those static files to the user within the browser. So again, multi-node clusters, if you have multiple gateways, just ensure that you have your custom logo file in the same place on each node to make sure that they get that same custom logo each time. Now, what should you be aware of? If you've been around Tableau Server for a while, and again, if you have multi-node clusters, you've probably heard the recommendation to have an external load balancer of sorts. It's important to note that an external load balancer doesn't remove the need for multiple different gateways, because the gateway will still determine where those requests go to after it hits that service. So user comes to the server, they log in. It's the gateway that's determining what the next step is going to be, regardless of where it sits on the nodes. But an external load balancer ensures that if one of those nodes goes down, then it still communicates the traffic to a gateway process to then go on. So if you're looking for a highly available Tableau server, then this is what you'll need to keep in mind. Ensure that that load balancer is there. And importantly, just again, what should you be aware of? The gateway is required if you have VizQL or Viz Portal, also known as application server, on one of the nodes. So there is our gateway. If you're interested in optimizing this further, Then, as I said, I'm a bit of a log whisperer. I tend to look for information there. There's a whole bunch of rich information that lies there. For those of you that are a bit more pro, you can actually look into the log files and you can see the exact requests that are sent to the gateway. So if, for example, your users are getting an error reaching the gateway, that will be captured in those log files. Or if you're noticing that or you think that there's a network issue, for example, likely you can find that out in the logs of the gateway. One down, Rick's now got to Tableau Server. He's now communicating with Tableau Server. He's there. The next thing he needs to do is log in. And the process that manages the login is the application server, or Viz Portal, as we just had another name for it. So Viz Portal / application server, what does it do? What should you be aware of? The first thing it does is authentication and authorization. So when Rick goes to that server, he hits the gateway. The next thing the gateway is going to do is go, I need to check if you're allowed to even be here. That's going to send it to the application server. It's going to get his username from the repository, and then say, OK, Rick, you exist. Are you allowed to access the server? If you're using local, it'll be in the repository. If you're using something like Active Directory, it's the application server that's going to go, hey, Active Directory, is Rick even allowed to be here? That's going to say yes, and we're going to proceed. The other important point is when, as a user, you're there looking at that web UI, that interface, seeing all the different projects, it's the application server that's rendering these images for your user. So again, any issues in just rendering that, potentially there could be an issue with the application server. So again, it manages all of this web UI rendering. But also it handles the publishing process. So if you're a user that publishes data sources, workbooks, any of these things, then when you go through that publish process, it's the application server that's going to go, OK, I need to divide this into the XML, the raw code behind it, and then figure out the actual flat files, and then store them in the correct place. That's going to be managing all of that side. Now, what should you be aware of? First things first, the default is 1 per node. You could have 2, but really that's only to try and provide additional redundancy within the same node. So again, if you're looking to ensure that nothing gets broken, nothing gets interrupted, then maybe have 2, but otherwise 1 is fine. It's actually not resource intensive. So you shouldn't ever see the application server spiking in terms of the amount of requests or capturing all your CPU and memory. But if that does happen, then chances are you're potentially using an incredibly heavy REST API or tab command request. So interesting story, a customer of mine that I've worked with quite closely was using tab command to generate over 10,000 images. So once a day, it would go run that script, download 10,000 images, a capture of every single screen and sheet. That starts putting intensive resources on the application server, but notably, it'll probably hit other things first before that even starts taking up resources. Right. So he's gone to the gateway. He's logged in. He's got his credentials. He's allowed to proceed. The next thing Rick needs to do is find content for him to access. And as the name implies, search and browse is the part of Tableau Server that will do that. Search and browse you can think of as being almost your Tableau Server's personal librarian. So anytime you're searching for content on that top bar and you type something in, it's search and browse that's going to go, oh, you've searched for sales. Here are some things relating to sales. Search and browse is the index behind that as well. So it's going to ensure, based on things within the repository, that for example, the content that's viewed the most comes to the top of that result. So we ensure within Tableau Server that the content people find is the most relevant as possible. So it's the search and browse service that manages that. Also worth noting that it's not required to be in the same place as the repository, even though it communicates with the repository quite a bit. It doesn't need to be in the same place, but it does need to be in the same place as the gateway and application server. And I'll show later on why that could be important for some configurations. So I mentioned repository a few times now, so it's probably best that we now cover this up. Rick's logged onto the server, he's accessing, he's communicating, he's searched for some content, he's found it. Now let's actually access that content, and he's going to use the repository to do that. So the repository is actually, in my mind, a hugely powerful piece of Tableau Server that is sometimes underused by people that have it sat there. The repository is actually a source of tons of application data. So again, possibly too much technical information, but worth oversharing than undersharing in these scenarios. Anytime you have a workbook, the code behind that workbook is actually XML. A Tableau workbook is written in XML language. When you publish that workbook or data source to Tableau Server, the XML code will actually go and sit in the repository itself. So it gets stored as part of the XML code and sits there waiting to be called upon the moment you need to access that workbook. The repository is also the source of really rich usage data. There are tons of examples out there on Tableau Public. I've got personal views that I like to use when I'm trying to judge how performant a server is. But it's the repository that goes through and tells you things like, how long do request times take? You can look up what's the 90th percentile of requests. Is that too high? Are we spiking too often? How much content do I have? What permissions on this content do I have? All of that is stored within the repository. And just to reiterate that, so not only can you see which permissions users have been granted by accessing the Tableau repository, but it also stores things like which groups do users belong to, and are they even allowed to access content in the first place? All of that is the source of this information. Again, what should you be aware of? The default for the repository is just one repository sat somewhere on the server. Again, for highly available or, I suppose, increasing redundancy on a Tableau server, then you'd likely have two repositories and that's it. You can't have more. It's just one active, one passive repository. It's not resource intensive. So likely the repository is never going to be a point in which your Tableau server is going to drain resources from. It writes things to it, it reads things to it, but it's never really intensive. Tableau also automatically streams data from the primary to the active to the passive repository, and it just does that continuously all the time. So in the event that the node with the active repository falls over, then the secondary repository will then take place. Words, need to say words. Right, an example of how you can use the repository to better your Tableau server. You have default admin views on your server, and actually there's a session tomorrow dedicated to how can you get the most out of Tableau server reporting. But you can also customize them. So this is a great example of something we use internally to judge how well something's performing. So right here, down here in the bottom left, for those of you on this side, it's all the way that way. You can see what we're looking for here is basically big red bubbles, because big red bubbles in this case indicate that there's lots of requests that are taking a long time to a particular piece of content. And the less red bubbles, the better. But more importantly, you can say things like, well, actually, this takes, on average, 24 seconds in this particular set of data based on a ton of hits, which is interesting. That's not too bad, but it's when you start going, OK, but the 95th percentile is actually a minute. So this is a good example of where we're identifying that there were issues here that we needed resolving. So that's custom admin views. And like I said, there's a session tomorrow that is focused solely around this topic. I really highly recommend it. Right, so Rick's gone through, he's got his content, we're ready to go. Let's start looking at the data server. So once we've got this content, the next thing we need to do is connect to the data behind it. And it's data server that does that. Data server is core and key to governance within a platform. When you're looking at extracts and live connections to a server on Tableau Server, that is data server in the background. There's only a need to ever have two data servers per Tableau Server. You don't need more than that. But what it lets you do is, first of all, have multiple connections to the same workbook and the same data source. So it handles all the parallel connections to content. It also acts as a proxy to those published data sources, so ensuring that all that, effectively, when you're dragging and dropping things around, it's making sure that that's sent in the language that the database understands. It also enforces permissions, so whether or not you're even allowed to see that data in the first place. It's data server that's just going to ensure that you can do the thing that you're trying to do. And lastly, it also centralizes the driver deployment. So for example, if you're using a Hadoop-based data source and you're using Apache Drill, let's say, then it's going to ensure that once you've installed the Apache Drill driver, then that's accessible across the server for everybody to use to communicate with that data source. Data server does all of these hugely important things that ensure that you're governing your server correctly. Another session to call out, specifically around this, is that there's a session again tomorrow called Optimizing Your Data Sources for Enterprising Data Strategy. And that's going to be about 2:30 to 3:30 p.m. tomorrow. Recommend looking at that if you want to have a deeper dive into what data server is actually doing behind the scenes. Right, so we've connected to our data source. We've got and established that connection. The next thing is the data engine. It's time to start querying this data source. And the query engine for us, for those of you that don't recognize it, go. It's Hyper. So Hyper is our German element of Tableau Server. It's the thing that's really cool. But most importantly, Hyper, so again, for those of you that don't know, we acquired it out of Munich roughly about 2.5 years ago now. And what it does is it does things like creates extracts, queries them, and operates query federation. So when you have cross-database joins, it performs that locally within a Hyper extract. But the important thing to note about Hyper is it's fast. It's very, very fast. The way that it queries things is incredibly fast. But what it also does is consumes as much CPU and memory as it can get a hold of. So who here has upgraded to a pre-Hyper version to a Hyper version? OK, a couple of people. Did you notice resource queries went up or spikes went up? A few nods. That was expected. It freaked a lot of people out, but that was fully, completely expected. The way that Hyper works is it tries to get a hold of all of that CPU and memory that it can get a hold of to ensure that it's operating and processing those queries as quickly as it possibly can. It's ensuring that that can be as fast and performant as possible. So it comes to the next question, which is, OK, fantastic, we've upgraded to Hyper. What happens if now we've noticed that we have extracts, and some of the queries on those extracts take quite a long time to process, upwards of, let's say, 5 seconds a query? We've actually introduced a new deployment methodology type called Hyper on a Standalone Service, which I will be referring to as HOS, because that is a long sentence. There is documentation online which calls it optimized for query-heavy environments. But again, HOS just sticks and rolls off the tongue. There's something about it. And the way that HOS works is effectively, as the name implies, is that you have the data engine in its own place. It sits on its own node, ready to compute extracts the moment they're accessed. It looks a bit like this. And you'll notice that the file store is with it, but then there's also data engine on the other nodes. A bit of, I suppose, learning on this point. So one of the things that the data engine does, as I said, is it manages query federation, which means that if your workbooks have multiple connections to different data sources, so some to SQL, some to, again, Apache Drill and Excel, the way that it manages that is it will bring that in memory to manage that operation at runtime. So the data engine needs to stay on those other nodes to work with VizQL. But ensuring that the data engine and just file store live on 2 and 3 in this scenario means that any queried or any extracts that are queried will be queried locally. So what should you be aware of with this? First things first, Hyper is, as I said, built to consume as much CPU and memory as it can get a hold of. That's the way that it queries things fast. It's what it's built to do. But it also scales up incredibly well. So if you're interested in using HOS, then potentially consider putting it on larger nodes, or the larger the node, the faster it will run those queries. One thing that you can actually do is, again, if you're a bit sad like me and like to look at log files, then you'll notice that within the Hyper log files, there's a flag, a spooling flag. And what that indicates is that whenever that spooling flag is true, the Hyper's run out of memory and has to start writing to disk. So if you like looking at log files, you can actually use that to say, OK, it looks like this flag is hit consistently, then likely we're running out of memory, and therefore we need to put more memory on our server. It's a nice way to make data-driven decisions with Tableau Server. You only ever need one data engine per node. You never need more than that. It recovers itself. That's the way it's built to handle. But it has to exist in the same place as backgrounder to create extracts, VizQL to handle federated queries, application server, data server, and file store just so it can do its job. Right, plenty there so far. We're starting to light up the board as we go through this user journey. So now we've started querying data. The next thing to point out that I mentioned is the file store. So as we saw before, file store lived in the same place as that data engine node. So what does it actually do? Why is it even there? Let's take this user scenario forward, and we've just got some content, a data source that we're going to publish to Tableau Server. What File Server is going to do is take that file, and when you publish it to the server, it's going to store it effectively. No surprises there, it is a file store. But importantly, what it does is, especially in highly available deployments, where you have multiple file stores, it's going to sync across those different file stores. So it's ensuring that those extracts, those files live across the nodes and are ready to be accessed in the event that something happens. So again, in fictional scenario, that middle node goes down. At least there's files, the same identical files in the other file stores ready to be queried. If you're like some of my customers and you've moved to a cloud environment and you've started trying to spin up and decommission nodes on a sometimes let's say twice a day basis, the important thing that you need to do is ensure that as part of that process, you decommission a file store. This is hugely important because in the event that data sources are midway through streaming, the last thing you want to do is can that, and then you've lost content. It needs to ensure that all the files exist everywhere, and then you can remove it. OK, so we've gone through our data journey. Rick's most of the way through his server processes at this point, and now it's time for him to load up his favorite dashboard. And to do that, he's going to use a little bit of help from VizQL. When we talk about VizQL, it would almost be rude to not mention these two people. This is Pat Hanrahan and Chris Stolte. They're the inventors, the creators of VizQL. And for those of you that are unaware, VizQL is a revolutionary visual language to database language. It's VizQL that, as you drag and drop, as you have your dashboards, those reports that are there on the server, it's VizQL that's turning all those visuals into some type of database language to then be processed, to then turn it back into some type of visual. In other words, it's VizQL that turns all those nice green and blue pills into SQL code, for example, or Apache code, or Oracle code. VizQL speaks multiple database languages fluently, and it's better at it than most of us, sadly. But VizQL is that piece of the puzzle that just makes all the things, the pretty things that all of us here care about. But also with that in mind, that dashboard that's in the back there, this is something that, as part of 2019.2, I'm actually going to be putting on Tableau Public as soon as I get some data that I can share that's sensible. And what this actually does is looks within the VizQL logs. So each one of those points, for example, in the top there, is a query that was processed by Tableau Server. You can also split this out to see what's the complexity level of a workbook, how many requests was it sending, and how popular is that content. I'm going to struggle to manage to do it from here, but the reason why it's 2019.2 and not earlier is because it uses show hide containers, because they're awesome. And then you can change what you're looking at from an axis and then go back. So I look forward to seeing that on public soon. If you don't follow me on Twitter, that's where it's going to hit first. Right. What should you be aware of with VizQL? With VizQL, typically it's two VizQL processes per node. Weirdly, there's only one there. It's probably going to pop up later. Each process can roughly handle a throughput of 50 active users at any given time. So importantly, throughput is the key word here. Because the more VizQL processes you have, the more throughput you get. There are the nodes. There were the things that were supposed to come up. So it can actually be increased and decreased. That count of VizQL can be increased and decreased without having to restart Tableau Server. So if you're interested in looking at the impact of changing the number of processes to see what more throughput would give you, then you can do so by increasing the number of processes without having to interrupt anything else that's going on at the same time. But as I said, more VizQL processes means more throughput. Does that mean more speed? Yes, no. Few nods, few shakes of the head. It doesn't necessarily mean more speed. It might mean, in the event that you have lots and lots of users accessing Tableau Server, having more nodes may allow you to handle those processes better, but it doesn't mean that it's going to handle them faster. It just means that they're going to not be queued as much. It does, again, also require data engine to be installed on the same node. Again, that's just for the query federation element that we were talking about before. Again, pretty dashboard. You can do so much with the information that lies within VizQL. And just for an example, difficult to see for those of you at the back. Let's see if zooming in works. Let's try that again. Yeah. Again, still very difficult to see, but there's a k-value called QP batch, for example, and QP batch records every batch set of queries that VizQL sent in order to be processed. So you can actually go through and see every single query that was compiled, and then how long it took to process, and which dashboard caused that query to happen. So again, some very neat stuff that you can do using VizQL. So Rick's loaded up his dashboard. It performed in less than 3 seconds. He's super happy. He thanks his server admin for that. And then he goes, actually, I think that this bit of content, this dashboard that we were just looking at, is relevant for one of his colleagues. So he reaches out to his colleague, Bono, and says, hey, you too should check this out. I'm sorry. So to do that, now that Bono's accessed the same dashboard, he's actually going to hit the cache server. This is where the cache server comes into play. The cache server handles these requests on behalf of the user. So for example, when they navigate to the same report, the same dashboard, if that's already been accessed, then the queries that were used, the images, the tiles that were used to form that dashboard, all of that's stored in the cache server. So they can actually access and preload some of that content. Importantly, that also works and rings true for data server. So if you're web editing and people drag and drop the same bit of content in, or the same fields in, then they're going to also hit the cache server. Same for application server, so all those images, all the folders, all of that stuff is cached, pre-cached, ready for people to quick load the images on server. And again, backgrounder works in the same way, so as much as it can that's cached, it can leverage. Important things to know about cache server is it's single-threaded, so similar to VizQL, the more you have, the more throughput that's available. But it's not CPU intensive, so again, it's never going to cause resource issues on your server. It only relies on memory, but an important thing that we've found through testing on Tableau Online is that the default is 2, but for truly, truly large environments, for those of you in this room that have upwards of, let's say, 10 to 20,000 users, you'll never really need more than 6. So it's the way that it handles and cycles cache, it does it very well. And we've never found a need for more than 6. Even at 6, you'll never use more than you actually need. It's also important that location, we found, isn't important. So again, for those of you that have been around Tableau for a while, if you're looking at older diagrams, you'll typically see cache in a 1-to-1 ratio with VizQL Server. So it'll be in the same place and have the same number of processes. We found that that's actually not required. It's not really true. If you want to put the 6 cache server all in the same place, on the same place as your backgrounder, for example, that's absolutely fine. It performs in exactly the same way. But also something else you should know. Let's take our fictional users, Rick and Bono, and they're accessing this beautiful dashboard from Skylar Johnson showing Spotify's top tracks in 2016. Bono goes there first, Rick goes there second. Rick hits the cache server because Bono's already loaded it. Fantastic. But what happens if we've got row-level security acting on this dashboard? Any guesses? Well, we're going to bypass that cache. The whole reason why is, let's say in this fictional scenario, Rick's got a genre as pop, and Bono has a genre of rock that he's allowed to see, or Irish rock, because there's no way they're really, truly rock. Importantly, when they go to that dashboard, to ensure that no way possible can they see the same data, can data leak out, then they're going to bypass things like the query cache. It just won't load for them. So, important bit on this topic, if this is something that you're interested in and how to better optimize, there is a session again tomorrow called Can't Touch This on row-level security in Tableau. Again, highly recommended attending that just specifically around this topic. Very quickly, one of the things that you could potentially do in this scenario, if you want to ensure that there's a cache ready for users to access, is to use, for example, tab command to pre-generate or pre-load a dashboard to ensure that that's hit first. So then acting as each user, then they've already got a pre-loaded individual view and hit the cache. Right. So we have our content, we've queried some data sources, we've loaded some views, and it's starting to look quite blinding with all these lights. And with that scenario done, we can also say farewell to Bono. So for those of you with eagle eyes, you would have noticed that the dashboard that we were looking at before was related to 2016. So we haven't run that extract in quite some time now. So it's probably due a refresh. And the process that's going to do that, we've mentioned it several times, it's been there in the background, hint, is the backgrounder. Now, the background is responsible for multiple things. Things like extracts, so creating those extracts. It's actually responsible for prep flows. So for those of you starting to play around with Tableau Prep, it's the backgrounder that's going to run those Tableau Prep flows. Anything like subscriptions, so all those user subscriptions where they've subscribed to their most wanted content, their top views. Background is going to handle the process of triggering those subscriptions to be sent out. And also, it handles alerts too. So if you have an alert, set a visual alert to say, send me a notification when this exceeds whatever value. It's the backgrounder that's going to periodically check that to ensure that that threshold has been set. A bit of a note on that one point, if when you're using alerts, you set a threshold like once any time it's true, and you have a live connection to that dashboard, it's going to do that roughly every 15 minutes to check to see if that criteria has been met. If you're using an extract, then it's going to run immediately once that extract is finished. So in this scenario, the backgrounder creates your new extract. The extract's finished. It then will send or check the alert and then send the alert if it's happened. That's a lot to remember, so just be aware that it's all of those things. There's a task menu within the Tableau server. All of the things that are listed within that task menu are run and handled by the backgrounder. So a few things that you should know. The default for background is actually 2 per node. And then when you think about all the things that it's actually doing, 2 per node isn't a huge amount. Similar to VizQL, and sorry, I forgot to say, I'll actually come back to that point. I'm not just going to let it sit in the ether. It can actually be increased and decreased without restarting Tableau Server. So for those of you that are sat there thinking, oh, that's quite interesting, what this opens up is because you can increase and decrease the number of VizQL and backgrounder nodes, or processes, sorry, if you're finding that, for example, you have lots of users accessing views during the day and lots of extracts running overnight, then you can actually increase the number of backgrounders during the night, decrease the number of VizQL, and then reverse that in the morning. So that ensures that people are having their requests processed as they're accessing views, and then backgrounder tasks are handling all those extracts at the same time. Similar to VizQL, the more backgrounder processes means more throughput. It can handle more tasks at once, so it can handle more extract refreshes without queuing those tasks. It doesn't necessarily mean more speed, it just means more things can happen at any given time. It also requires the data engine to be on the same node. Again, the reason why is it's the data engine that's actually doing all that querying and building, but it's the backgrounder that just handles that task. And this point's probably the most important. For those of you that are fairly new to Tableau Server management, the backgrounder is actually one of those tasks that can be very highly CPU, disk I/O, RAM intensive. It handles a lot of things at any given point in time. What typically happens, and what we've seen happen, is users like extracts. Extracts are fast, so of course they like them. They then publish those extracts to the server, set it on a schedule. You all of a sudden have tons of schedules running lots of extracts, and then the backgrounder gets quite intensive. What you can do to ensure that this doesn't impact those users loading content at the same time is isolate it. If you have a query-heavy environment that uses lots of extracts and you just have lots and lots of extracts, then isolate the backgrounder. So what this looks like is this is our typical default one node, out of the box, nothing special, Tableau Server configuration. If you drop the backgrounder from that first one, what it allows you to do is put it on its own node and increase the number of backgrounders running on that node. It's actually interesting when we look at default number of recommended processes here. So the default recommendation is actually, it's say n over 2. If you're on a single node, it's n over 4, but by itself, it's n over 2, n being the number of cores. But actually, what I've found is going as much as n minus 2. So if you have 16 cores, you can go as many as 14 backgrounder processes on that single node, and you'll actually not be impacted. It'll still handle that throughput and still handle those tasks. So isolating backgrounder is a good, solid trick for ensuring that your content doesn't interfere with each other. Now, with the backgrounder in mind, I mentioned that the backgrounder runs prep flows. So what does the prep conductor do? Let's find out. So with 2019.1, we introduced prep conductor as an option to Tableau Server. And what prep conductor allows you to do is publish flows to Tableau Server. You can see here, here's an example of a flow published to Tableau Server. It shows you what those steps are doing. It shows you the tasks that have recently happened, where the outputs are going. It's Prep Conductor that's managing all of those bits and pieces. Prep Conductor is responsible for running that flow. It checks to see if connection credentials are met, so again, ensuring that you can actually run that flow in the first place, and tracks the history and, importantly, sends you an alert if that flow fails for whatever reason. So if all of a sudden the credentials have changed, they've expired, prep flow will let you know it's failed and why that's happened. But again, hang on a second. We've just gone, OK, so prep conductor's there, but where does the backgrounder come into play? Let's go to our isolated backgrounder step that we were just looking at. What actually happens here is the moment that that flow needs to be run, the backgrounder is going to manage that process. And what you're actually able to do within a Tableau server environment is classify whether a backgrounder process is allowed to run prep flows or not allowed to run prep flows. Or if it just wants to handle extracts, you can say it should just do nothing but handle extracts. Now, a recommendation, this is still a growing area. We're still figuring out the impact. My personal recommendation through my own testing is that if you're using Tableau Prep is more intensive than creating an extract. That's quite natural. It has a lot of transformation steps. It needs to do quite a lot of things in order to create that output. And sometimes there are multiple outputs as part of that flow too. So if you're using Tableau Prep, it's generally a good idea to also isolate Prep's backgrounders, which means we can start doing something like this. Let's now take this as an example. In this fictional Tableau Server configuration, what we've actually done is we've ensured that Prep flows are isolated. They're not going to impact anything else on Tableau Server. And also, we've got lots of extracts, so we've also isolated the backgrounder. If you've got lots and lots of things that are extract heavy and prep flow heavy, then it's probably a sensible idea to ensure that they're separated out like this, and you can handle them individually. So a few things to know about Tableau Prep Conductor. As I said, prep flows are more complex than extracts. That shouldn't necessarily be surprising, just because of all the transformation steps they're doing. And because of that, just to reiterate that point, isolation is highly recommended in the event that you're using Tableau Prep. You can also use TSM commands to set whether or not a backgrounder process handles flows or doesn't touch them entirely. For example, these here. This is all documented, by the way, so don't worry about keeping track of this. But importantly, you can basically say this should handle flows or no flows, or both, depending on the amount of extracts and flows you have in your environment. We are almost there. We've got all the processes starting to light up, and the big one glaring right there in the middle is our lovely new Ask Data. You saw that demoed on stage by Francois before, and now Rick's going to go and ask a few questions of his favorite data source. Ask Data is actually split into two components. The first, if you're looking at a list of processes, is something called Elasticsearch. When you go to any data source, Ask Data will start kicking in. It will start indexing that data source to figure out the metadata behind it to understand what you're actually going to start asking. And Elasticsearch is going to handle that process. It stores the metadata to figure out what type of fields are there, what's the most common, what's the highest result, the minimum result, and it stores all of that good information ready to be queried. The next, if you're looking at a list of processes on Tableau Server, is the Ask Data process itself. The Ask Data process is the bit that turns that user typing, or if you're a Francois in his case, spelling mistakes, turns those good spelling mistakes into a bit of understandable query to be sent to the data source. But we're not actually quite done. Once you've asked your question, so for example, what's the close price per day, filter stock name, so it contains Tableau. Once that's sent, it's turned into whatever code sits behind that data source. And you guessed it, we get our data engine involved again. So it's the data engine that's going to handle that query that the Ask Data Server creates, processes it, and then returns the results, again, using VizQL to generate the line. So actually, Ask Data leverages and uses all the bits of Tableau technology that's already there on Tableau Server already. So a few things that you should note if you're starting to use Ask Data. Any data source is set by default to something called triggered by user request, which means that once a data source is published to Tableau Server, or if it's already there, a user can start asking questions in Ask Data. It's there, ready to use. You can actually set this to be automatic, so all data sources, if the moment you turn it to automatic, it starts refreshing the metadata. Or you can turn it off, which is if you have a huge data source that in no way do you want people asking questions of, you can also disable it. Fantastic news. It also has a set heap size for the Elasticsearch service. So like I said, all that metadata, all that useful information that's going to be leveraged when you start asking questions, you can actually increase that size of memory it provisions if you find that you have lots of data sources using Ask Data. And again, it uses and leverages the data engine to query those data sources. So scaling is going to actually be dependent on everything else anyway. It's not going to be necessarily more demanding than loading a workbook. If anything, potentially less because of the things that you're likely doing. Right. So we've gone through this user journey. All of those lights at the top are now lit up. Fantastic news. At this point, we can let Rick go. We're never going to give him up, but we will let him down. And we can introduce ourselves to our final 1990s pop star, which is Pirate Madonna. Pirate Madonna is our server admin virgin, and she's about to touch Tableau for the very first time. And the two things that she really needs to be cautious of or aware of is the cluster controller and TSM. So these two bits that we're yet to touch. Now let's break all of these things down. There are 6 key components that fit into the boxes at the bottom of the screen, and they are the cluster controller, licensing server, the client file service, coordination service, admin service, and finally the Tableau Services Manager. Each one has its own key part to play in the management and governance of a Tableau server process. The first thing is the cluster controller. So whenever you're looking within your Tableau Server status tab, it's the cluster controller that's reporting to you to say, hey, this is healthy, hey, this has gone down. Cluster controller manages and monitors all of those services to make sure that they're working. If, for example, as we discussed before, your repository goes down, it's actually the cluster controller that's going to trigger that automatic failover to take place. So it gives it a second to see if it's going to come back. It's determined that it's definitely gone down. Right, our passive repository, our secondary repository kicks in now. The licensing service is the next key thing to be aware of. The licensing service lives only on the initial node. So for those of you that have used Tableau Server for a long time, you'll notice that there's no concept of a primary node anymore. That's gone. But there's still an initial node, which is literally the node that's installed first. On that node is the licensing server. What the licensing server does is every 72 hours goes, I need to do a check to make sure that this Tableau server is licensed, that the license key that we have is valid and ready to use. So it communicates with that licensing server and reports that check. Again, key thing to know is in the event that, let's say, that initial node goes down, if there's no way to recover that initial node, first things first, you can recover the initial node and things are fine. But if there's no way to recover it within roughly a 72-hour window, then likely you'll have to move that licensing server onto a new node to ensure that everything remains licensed. The client file service, the next one, or CFS for short, for those of you with super good vision, I'm not one of them, you can notice there's a little Kerberos icon on that certificate because the client file service manages things like certificates for the server. So if you're using single sign-on or Kerberos, then all of those Kerberos certificates are managed by the client file service. Important thing with client file service is install it everywhere where the coordination service is, which brings us on to our next process. The coordination service is actually the source of truth for quorum. So if you're setting up a Tableau server cluster that needs to be highly available, you should have at any given time 3 or 5, depending on how big your Tableau service is, coordination service ensembles. What they do is determine which one acts as the leader in the point of any decision. So in the event that something goes down, they can still determine who makes the correct decision. The coordination service ensures that quorum is met and your server is highly available. Next up is the admin agent. The admin agent is the bit that handles all those TSM requests, the changes, the things like that hot topology that we were talking about before. Or if you add a new node to the cluster, it's the admin agent that ensures that those configurations are replicated, checked, and happen within your service. It'll actually install itself on every single node, so it's always there. You don't have to worry about it not being there. And the very last point within this little section of our Tableau server is the Tableau Services Manager, or TSM for short. So for those of you that are on Windows deployments, we introduced this as part of 2018.2. Now everybody has TSM. Before that, it was only available on Linux. And TSM is that bit where you can remotely connect and manage your Tableau server from wherever you are, so long as you can access that TSM component. Again, it automatically installs itself wherever across each node, so it's always available. And again, it's really unique in terms of, we call it admin at the beach. So if you're on the beach and you really want to add a new node to your cluster, then you absolutely can without sacrificing that tan that I don't get. Right, so we have covered absolutely every single process in a very short amount of time. I've thrown information at you. If you're really interested in learning more about this, I've given you a few sessions that are available later on today and tomorrow. But there's also this workbook available on Tableau Public. What this lets you do is, it's within our official Tableau software public page. You can say, what type of workflow do I want to see from our Tableau server interface? So for example, this was a user logging in with Active Directory. And then you can flick through and see all the different processes it's going to hit as part of that journey. So as I said before, if we're logging in with AD, you can see it hits the application server, ensures that it gets its username from the repository, goes, speaks to the AD unit, comes back, and then they can log in. So you can go through those user journeys and see that come to life. And then a quick recap on the most important things that I think you'll take away from an optimization and configuration standpoint is this is the default Tableau server installation. For a single node, this is the default. If you have more users, then you have two options. You can scale up the number of processes, you get more throughput, and you can better leverage the resources that you have on that machine. If you're starting to hit and use up all that machine capacity, then you can scale out and just handle just more users in general. If you've found that you have lots of queries that are query intensive, then you can go and use HOS right at the very end and isolate the data engine aspect. If you have lots of extracts, you can isolate the backgrounder specifically for querying extracts. And if you have lots of query flows, then you can also isolate the prep aspect of backgrounder too. Or if you have lots of everything, then you can isolate absolutely everything, scale everything up, out. What's your budget? Let's talk about that separately. Final few points. So we've had our 1990s pop stars take us through the journey, but mainly that user journey point covers everything from Viz Portal, VizQL Server, all of those things that we saw in the top half of the screen. Our server admin will cover the 6 components that can be wrapped up into Tableau Server services. And hopefully you have all taken a peek inside the box and can be much happier with the way that Tableau Server is set up. Squeezed it in with a minute to go. Thank you very much for taking part today. Thank you for being a great audience, and I'll be around for questions. Oh.